When you first look at this problem, you're probably going to panic because you're going to look at this number right here. 51 quintillion, 90 quadrillion, 942 trillion, 171 billion, 709,440,000. What on earth? That's a gigantic 20-digit long number. We also know that it has over 60,000 positive integer divisors. We're choosing one of those at random. We want to find a probability using this. Now, most people would panic because this is literally 20 digits long, but let's just take a step back. Let's look at what it actually even means to be an odd positive integer divisor. And, this is basically just equal to factor. So let's look at what it means to be an odd factor. So first, I'm just going to write down the prime factorization of 51 quintillion, so on and so forth, whatever this number is. So you can write this as 2 to the a times 3 to the b times 5 to the c times 7 to the d, and so on and so forth, all the way until the primes that are less than or equal to 21. So the maximum prime is 19, and we'll just call that to the n. So this is going to be the actual prime factorization of this. Now we know that a factor of this, so a factor of 21, is going to be something like 2 to the little a times 3 to the little b times 5 to the little c, all the way up until 19 to the little n. And these little numbers are chosen such that a is always going to be less than or equal to a, b is always less than or equal to b, and so on and so forth, and n is always less than or equal to n. This is how we even construct a factor in the first place. A factor is constructed by choosing some random numbers that we're going to leave out. So for example, let's just take a look at a simpler example. Let's just look at the number 21 itself. We can write this as 3 to the 1 times 7 to the 1. So that means that big A, or in this example, this exponent is 1, this exponent is 1. So when we're constructing factors, we can have a 3, we can have a 7, and we can choose, is this one going to be 1, or is this one going to be 0? And we can choose, is this one going to be 1, or is this one going to be a 0? So this could be a 1, this could be a 0, this could be a 1, this could be 0, and that's why 21 has 4 different factors. That's how you calculate the number of factors, because this is literally how you construct a factor. Now this is how you construct a factor for 21 factorial, is you choose some number a that is less than or equal to a, like we did here. So if a is less than or equal to a, then this one is going to be a factor of this one, and then b is less than or equal to b, this is a factor of this, so on and so forth. So now that we know how to choose a factor, this is like we can calculate how many of them are even. Now if factor is even, that means we have to know that if factor is even, or factor is an odd, that means we know that a has to equal 0. We can't have any factor of 2, and likewise if it's even, that means we know that a has to be greater than or equal to 1. So because we want to find the probability that it's odd, we want to find the probability that our factor is going to have an a of 0. And so what literally doesn't matter is b doesn't matter, c doesn't matter, and none of these actual other things matter because they're all like, I guess, random. The only thing that matters is the exponent we choose a, so the number of a we choose. So the a is less than or equal to a. Is a equal to 0? What is the probability that a is equal to 0, given that, a is less than or equal to a, and we can also put a lower bound on it. So this is a massive simplification of this problem. We don't even care about this number. We just want to find the probability that a is equal to 0, given we're choosing uniformly, you're choosing integers from 0 to a. Now big A. Now we want to calculate big A. That's the second step. To calculate big A, we just need to find how many factors of 2 there are. So for 21, here's a little trick I use. So 21 divided by 2, and the floor of that equals 10, means that there's 10 factors of 2 in 21 factorial. I mean, this is just like a rough count so far, so there's 10 factors of 2 so far in 21 factorial. And the way you can see this is that there you can count 2, then there's 4, 6, 8, 10, 12, and so on and so forth, all the way up until 20. So each of these numbers in the factorial expansion is contributing a factor of 2. So we can add 10 factors of 2. But we're not done, because we also have to look at factors of 4, because factors of 4, like 4, 8, 12, these guys are also contributing an extra factor of 2, because that's just 2 squared. So we now want to look at the extra factors of 2. So 21 divided by 4, and the floor of that is 5. Next, we go for the next one, 21 divided by 8. The floor of that's going to be 2. 21, 16, because each of these 8, this is contributing an extra factor if it's divisible by 8. If it's divisible by 16, it's contributing even an extra factor on top of being divisible by 8. So we keep on doing this, so on and so forth, until we reach 0, because 21 by 32, the floor of that is 0, and so the next ones are always going to be 0. So summing this, well, that's 15, this is 3, and that's 0, so 15 plus 3 is 18. So in total, there are 18 total factors of 2 in 21 factorial. So that means a is equal to 18. So now we're choosing a number, 0 less than or equal to a, less than or equal to 18, and we want to find the probability that a is equal to 0. Now note that it's not actually 18 numbers, 18 integers we're choosing from. There's actually 19 because we have to include the 0 and, assume that this big A is like 7 here. So if we're going to choose that like 0, 1, 2, 3, 4, 5, 6, 7, 7 would only mean we're choosing from these numbers. So we have to add 1 to include the 0. So that means we're actually choosing out of a total of 19. There's only one number that we're choosing, that's the 0. So the answer is 1 out of 19. Notice that if we don't panic when we look at this gigantic number, we can actually make a lot of progress. This number doesn't even matter. What matters is the number of factors of 2 in the expansion of 21 factorial. So don't panic when you see 51 quintillion on your next exam.